Temperature measures how hot or cold an object or system is, essentially reflecting the intensity of molecular thermal motion within it. But have you ever wondered what the highest possible temperature in the universe could be, or how low the lowest temperature might go? Theoretically, temperature has no upper limit. It can reach any extreme height because, at the microscopic level, temperature is determined by the intensity of particle motion. The faster the particles move, the higher the temperature. This motion can intensify as energy increases. Within the framework of special relativity, although particles with mass cannot reach the speed of light, their kinetic energy can increase indefinitely. As a particle's speed approaches the speed of light, its kinetic energy also approaches infinity, and thus the temperature approaches an infinitely high value. However, in the universe, temperature has never reached infinity. This is purely theoretical. The highest known temperature in the universe occurred approximately 13.8 billion years ago, at the very moment of the birth of the universe, the first Planck time after the Big Bang. This temperature is known as the Planck temperature. Based on modern cosmological models, scientists estimate that at the moment of the Big Bang, the temperature reached about 1.4 times 10 to the power of 32 degrees Celsius. This temperature, none of the matter we know today, atoms or fundamental particles, existed. Moreover, the four known fundamental forces were unified. As the universe expanded and cooled, such extreme temperatures have never been observed again. Now let's discuss the lower limit of temperature. While temperature has no upper limit, it does have a theoretical lower limit, absolute zero, which is minus 273.15 degrees Celsius. However, absolute zero is unattainable. As mentioned earlier, the temperature of an object is determined by the thermal motion of its internal particles. The more intense the motion, the greater the average kinetic energy, and thus the higher the temperature. Conversely, as particle motion approaches a standstill, the temperature approaches absolute zero. In quantum mechanics, all microscopic particles that make up the universe are governed by inherent uncertainty. Their position and momentum are constantly fluctuating and never come to a complete stop. This means absolute stillness is impossible in the quantum realm. If particles were to stop, their position and momentum would become precisely defined, violating the uncertainty principle of quantum mechanics. Furthermore, the third law of thermodynamics states that absolute zero can never be reached. It can only be approached infinitely. This is because any space must contain some energy and heat. As a result, absolute zero remains forever out of reach.